Number 10.
LHS 1140b is a super-Earth orbiting a red dwarf star about 40 light-years away. In cosmic terms, that's close. Really close. Close enough to start feeling uncomfortable. The planet is about 1.7 times Earth size and nearly 6 times more massive. That means much stronger gravity. If you stood on its surface, you'd weigh about 3 times more. Every step would feel like you're carrying invisible furniture. Jeff. I'd fall over once and just accept my new life on the floor. That massive weight suggests LHS 1140b is rocky, with a large iron core, similar to Earth, just upgraded. It orbits in the middle of the habitable zone with a year lasting only 25 days. 1 month. That's a full year. No long seasons. No waiting. Just constant Happy New Year energy. Jeff. Imagine aging 12 years every Earth year. Absolutely not. Because of its strong gravity, LHS 1140b likely holds onto a thick atmosphere. Gases don't escape easily. Heat stays trapped. Radiation gets blocked. Life gets better protection. Basically, the planet is wearing heavy armor. Recent observations suggest something even more interesting. The surface might be covered by a global ocean. No continents. No beaches. No mountains. Just water. Everywhere. If that's true, LHS 1140b would be a full water world, with oceans far deeper than anything on Earth. Jeff. So the aliens here are definitely fish. Any life on this planet would likely be entirely aquatic. Swimming. Floating. Adapting to pressure. Possibly building underwater civilizations we'll never see. Meanwhile, the star itself is older than our Sun and much quieter than most red dwarfs. Fewer violent flares. Less radiation. More stability. Which is rare. And valuable. That makes LHS 1140b one of the best candidates for life we've ever found. A thick atmosphere. Possible global ocean. Stable star. Long-term habitability. All the ingredients. Future telescopes may be able to analyze its atmosphere and search for biosignatures, chemical signs of life. One day, we might detect oxygen, methane, or something completely unknown. And realize that under hundreds of kilometers of alien ocean, life has been thriving this whole time.
Number 9.
On April 18, 2013, NASA announced the discovery of a 5-planet system about 1,200 light-years away in the constellation Lyra. At the outer edge of that system was one strange world. Kepler 62f. A planet orbiting near the cold edge of its star's habitable zone, receiving only about 41% of the energy Earth gets from the Sun. By every normal rule of physics, this planet should have been frozen solid. A drifting ice ball. No oceans, no life, no hope. Scientists ran the models, saw permanent glaciers, and moved on. Jeff. Imagine getting labeled dead planet and nobody double-checks. Kepler 62f is a super-Earth, larger than our planet, and early simulations agreed on one thing. Total deep freeze. Case closed. Until 2016. That's when astronomer Aomawa Shields at University of California, Los Angeles published research that changed everything. Her team's atmospheric models revealed something unexpected. If Kepler 62f has carbon dioxide levels just 3 to 5 times higher than Earth's, plus a small amount of methane, the planet could stay warm all year. With liquid oceans. That thick blanket of gas would trap heat through the greenhouse effect, transforming a frozen wasteland into a temperate ocean world. From space iceberg to alien beach planet. All because of air. For decades, scientists believed habitable zones were narrow rings where planets got just enough sunlight. Too close, you burn. Too far, you freeze. Kepler 62f proves that habitability isn't just about distance. It's about atmospheric chemistry, something we can barely measure for most exoplanets. Which means many planets we've dismissed as too cold could actually be warm, wet, and alive. Jeff. So aliens might be out there like, they skipped us because we were chilly. Kepler 62f has a year of about 267 days, not much longer than Earth.
Number 8.
452b orbits a star remarkably similar to our Sun, about 1,400 light-years away. The star is only 10% larger and 20% brighter than ours, making it one of the closest solar twins we've ever found. Its planet, Kepler 452b, is about 60% larger than Earth, classifying it as a super-Earth. Bigger planet. More gravity. More pressure. More consequences. Jeff. So it's Earth, but with gym membership. Kepler 452b orbits in the habitable zone with a 385-day year, almost identical to Earth's. 1 year there is basically 1 year here. No weird calendars. No alien leap weeks. Just vibes. Jeff. Great. Even aliens have deadlines. Here's the scary part. This planet has been sitting in the habitable zone for about 6 billion years. That's 1.5 billion years longer than Earth. Which means if life followed a similar timeline, it had a massive head start. While we were learning how to walk, they might have been building cities. While we were inventing fire, they might have been inventing excuses not to visit us. Jeff. Bro, they probably finished their tech tree already. Kepler 452b is likely rocky, with much stronger gravity than Earth. If you stood on its surface, you'd weigh about twice as much. Every step would feel like leg day. Forever. That stronger gravity could also mean a thicker atmosphere. Better at trapping heat. Better at blocking radiation. Better at protecting life. Basically, premium planet packaging. The biggest mystery is water. We don't know if Kepler 452b has oceans. But its position in the habitable zone for billions of years suggests that liquid water could have formed, and stayed. Oceans. Rain. Rivers. Possibly entire alien ecosystems just minding their business.
Number 7.
TOI 700D. On January 6, 2020, at the 235th meeting of the American Astronomical Society, astronomer Emily Gilbert announced a discovery that made scientists look much closer to home. Using data from NASA, researchers found an Earth-sized planet just 101 light-years away. That's close. In space terms, that's practically across the street. It orbits a stable red dwarf star in the habitable zone, where liquid water could exist. Jeff. So aliens might be living in our neighborhood and never said hi. TOI 700D is about 1.1 times Earth's size, receives roughly 86% of the energy Earth gets from the Sun, and completes one orbit every 37 days. 1 year there is barely over a month. No long waits. No slow seasons. Just constant motion. At first, it seemed like another interesting planet. Then, in January 2023, everything changed. The James Webb Space Telescope turned its instruments toward TOI 700D. And detected possible signs of an atmosphere. A protective layer of gas. Something that could trap heat. Block radiation. And support life. Jeff. So the planet might actually be wearing sunscreen. The data is still being analyzed. Nothing is confirmed yet. But even the possibility of an atmosphere turned TOI 700D into a priority target for future research. Because atmosphere means potential habitability. Climate models now paint two very different futures for this world. In one scenario, TOI 700D is a global ocean planet. No continents. No dry land. Just endless water under thick clouds. Life would evolve in a permanent sea. In the other scenario, it's a cold desert world. Most water is trapped in massive ice caps at the poles. Liquid water only exists in narrow twilight regions. Between frozen and warm. Between day and night. Jeff. So it's either water world or ice level. No middle ground.
Number 6.
GJ667cc is a super-Earth located just 24 light-years away in the constellation Scorpius. Discovered in 2011, it orbits a red dwarf star with a mass about 4.5 times that of Earth, placing it inside the habitable zone. But this system is different. Its host star is part of a triple star system. From the planet's surface, you wouldn't see one sun. You would see 3. Jeff. 3 suns? That's not a planet, that's a boss level. GJ667cc orbits extremely close to its main star, completing 1 year in just 28 days. This distance almost certainly causes tidal locking, meaning one side of the planet always faces the star, while the other remains in permanent darkness. One side burns. One side freezes. No balance. Or so it seems. Despite its strange orbit, GJ667cc receives about 90% of the energy Earth gets from the Sun. But most of that energy arrives as infrared radiation, not visible light. The result is a world bathed in dim red twilight, darker than Earth's daylight, but still warm enough for liquid water. Jeff. So the whole planet looks like it lives inside a gaming PC. If the planet has a thick atmosphere, heat could move from the hot side to the cold side. This would create a narrow, stable region called the terminator zone, the boundary between eternal day and eternal night. In this band, temperatures could remain steady for billions of years. No seasons, no ice ages, no extreme weather. Just permanent balance. Life evolving there would grow up in the most stable environment imaginable. Jeff. Meanwhile, Earth is like, surprise hurricane. GJ 667cc shows us that Earth-like doesn't always mean better. Some of the most promising worlds may look nothing like home. And somewhere under 3 suns and a red sky, life might be thriving in ways we never expected.
Number 5.
On December 5, 2011, NASA announced something scientists thought would take decades. The Kepler Space Telescope had confirmed a planet orbiting in the habitable zone of a G-type star, the same class as our Sun, about 620 light-years away in the constellation Cygnus. That planet was Kepler 22b. It completes an orbit every 290 days and receives about 25% more stellar energy than Earth. Its host star burns at roughly 5,757 Kelvin, almost identical to our Sun's 5,778 Kelvin. In nearly every measurable way, this is a solar twin system. Same type of star. Similar temperature. Habitable zone orbit. It was the first confirmed example of an Earth-zone planet around a Sun-like star. And then, everything got complicated. Kepler 22b has a radius 2.4 times larger than Earth's. That places it in the awkward middle ground between a rocky super-Earth and a gaseous mini-Neptune. And here's the problem. We don't know its mass. It's too distant for precise radial velocity measurements. No mass means no density. No density means no composition. No composition means we have absolutely no idea what this planet actually is. Jeff. So we hyped it up for 13 years and still don't know if it's rock, water, or cosmic soup. If it's rocky with a thick atmosphere, it could be a massive super-Earth with deep global oceans and heavy cloud cover. Life there might thrive beneath dense skies, in warm, shallow seas. If it's a water world, the entire planet could be covered by an ocean hundreds of kilometers deep. No continents. No beaches. Just endless water, with high-pressure ice forming at the bottom under crushing gravity. Life, if it exists, would live in permanent deep-sea conditions. Across the entire planet. Or it could be a mini-Neptune. A small rocky core buried beneath a thick hydrogen-helium envelope. Beautiful. Blue. And completely uninhabitable.
Number 4.
Kepler 442b orbits an orange dwarf star about 1,200 light-years away. Not a red dwarf. Not a sun twin. An orange dwarf, slightly cooler and smaller than our Sun, but far more stable and longer-lived. And in the search for life, stability is everything. Orange dwarfs are often considered ideal stars for habitability. They're bright enough to power photosynthesis, but calm enough to avoid the violent flares that plague many red dwarfs. Basically, not too chaotic. Not too boring. Just right. Kepler 442b itself is about 30% larger than Earth and completes an orbit every 112 days. A short year. Efficient. No wasting time. It receives about 70% of the light Earth gets from the Sun, making it slightly cooler overall. But if it has a thicker atmosphere, which is very possible for a planet of its size, that extra greenhouse effect could trap enough heat to maintain liquid water on the surface. Cool star. Thick atmosphere. Steady warmth. The planet's size suggests it's rocky, and possibly massive enough to support active plate tectonics. That matters. Plate tectonics recycle nutrients, regulate carbon dioxide, and stabilize climate over long timescales. In other words, they help keep a planet alive. Scientists estimate Kepler 442b has about a 97% chance of being within its habitable zone. That's higher than almost any other known exoplanet. A near-perfect alignment of star type, planetary size, and orbital distance. If you were building a world designed for life, this would be close to the blueprint. Jeff. So there's a 97% chance aliens picked the better neighborhood.
Number 3.
Kepler 186f, the first confirmed Earth-sized planet in the habitable zone. On April 17, 2014, astronomer Elisa Quintana stood before the world and announced something that quietly changed humanity's self-esteem forever. The Kepler Space Telescope had detected a planet 582 light-years away, in the constellation Cygnus, almost exactly Earth size, about 1.1 times our radius, orbiting inside its star's habitable zone. For the first time in history, we confirmed that Earth-sized worlds exist in regions where liquid water could flow. In other words, planets like ours are not special. Wait. So we're not the main character? I hate this universe already. Kepler 186f orbits an M-type red dwarf star, receiving only about 32% of the energy Earth gets from the Sun. By normal logic, that should make it a frozen wasteland. An eternal ice age. A planet where Antarctica would book vacations. It sits on the outer edge of its star's habitable zone, where scientists usually expect nothing but glaciers, permafrost, and disappointment. So it's basically the freezer section of space. But here's where things get interesting. Kepler 186f's fate depends on something we cannot measure from 582 light-years away. Its atmosphere. If the planet has enough greenhouse gases, maybe just a few times Earth's carbon dioxide levels, it could trap heat and stay warm. Warm enough for oceans. Warm enough for rain. Warm enough for life. Jeff, you're telling me aliens might exist because of space pollution? That's poetic. With the right atmosphere, this frozen world could actually be a temperate planet of seas and continents, glowing under the dim red light of its ancient star. A quiet ocean world. A shadowy coastline. Possibly filled with creatures staring back at us, right now. Jeff. Stop saying that like they're watching this video. The discovery of Kepler 186f proved something huge. Red dwarf stars, which make up about 70% of all stars in our galaxy, can host Earth-sized planets in habitable zones. That means most stars in the Milky Way might have worlds like this. And if even a small fraction of them keep thick atmospheres. We're not talking millions of habitable planets. We're talking billions. Jeff. Billions? There's definitely at least one planet where aliens already replaced us and are doing better.
Number 2. TRAPPIST-1e. Meet TRAPPIST-1e. A planet sitting about 40 light-years away, orbiting an ultra-cool red dwarf star called TRAPPIST-1. It's roughly Earth-sized and sits directly in the habitable zone, the region where temperatures could allow liquid water to exist on a surface. First of all, 40 light-years is way too far. I get tired going upstairs. TRAPPIST-1e is tidally locked, meaning one side of the planet always faces its star. That side experiences eternal daylight, while the opposite side is locked in permanent night. No sunsets. No sunrises. Just commitment. So the planet is either always awake or hasn't replied in 6 billion years. Between these two extremes is a twilight zone, a narrow band around the planet where temperatures could be stable enough for life. Scientists believe liquid water could exist in this region, especially if the planet has an atmosphere capable of moving heat from the hot day side to the cold night side. Imagine surviving because the atmosphere said, "Alright everyone, share." TRAPPIST-1e receives about the same amount of radiation from its star as Earth gets from the Sun, despite orbiting much closer. The star is dimmer, cooler, and smaller, but physics balances it out. The planet's density suggests a rocky composition, with a large iron core, similar to Earth's. Meaning gravity would feel uncomfortably familiar. Great. Even on another planet my knees still hurt. The star itself is a red dwarf, and red dwarfs burn fuel incredibly slowly. They can remain stable for trillions of years, giving potential life far more time to evolve than life ever had on Earth. More time to adapt. More time to get strange. Trillions of years. That's enough time to invent alien taxes. However, red dwarfs have a dangerous habit. They frequently release powerful stellar flares, bursts of radiation strong enough to strip away a planet's atmosphere. If that happens, liquid water disappears, and life doesn't stand a chance. Unless TRAPPIST-1e has a strong magnetic field. If it does, that magnetic shield could deflect the radiation and protect the atmosphere, just like Earth's does. So the entire fate of life depends on whether the planet remembered to turn on its shield. TRAPPIST-1e isn't a second Earth. But it's one of the most promising Earth-like worlds we've ever found. Number 1.
Proxima Centauri b, our closest possible alien neighbor. Proxima Centauri b is the closest known exoplanet to Earth, just 4.2 light-years away. In cosmic terms, that's next door. Not across the galaxy, not across the universe. Next door. It orbits Proxima Centauri, a red dwarf star and our nearest stellar neighbor. A small, cool, dim star. With very big attitude. Jeff. So aliens are basically living in the next apartment. The planet is slightly larger than Earth and sits inside the habitable zone, where liquid water could exist. Its orbit takes just 11 days. 1 year there is less than 2 weeks. No long summers, no long winters. Just constant. Is it already New Year again? Jeff. Taxes every 11 days is criminal. Because it orbits so close, Proxima Centauri b is likely tidally locked. One side of the planet always faces the star. The other side is stuck in permanent night. The day side could host liquid oceans. The night side may be frozen solid. And between them lies a narrow twilight zone where temperatures could be just right for life. Jeff. So aliens live in the hallway between fire and ice. Recent studies suggest the planet may have an atmosphere. If it does, powerful winds could move heat around the planet, keeping temperatures stable enough for water and possibly biology. That's the good news. Here's the bad news. Proxima Centauri is extremely active. It regularly unleashes massive stellar flares that blast the planet with radiation. Enough to strip atmospheres. Enough to damage DNA. Enough to ruin everyone's day. But if Proxima Centauri b has a strong magnetic field, it could deflect much of that radiation, just like Earth does. A cosmic shield. Without it, life struggles. With it, life has a fighting chance. And because this planet is so close to us, it's a prime target for future missions. One day, we may send probes. We may analyze its atmosphere.